back to the another lab of soil mechanics. Till now we have performed different experiment to observe the different physical properties of soil. As we have already discussed in the class, one of the important property of soil is the permeability. So in the lab we decided the permeability of soil through two tests, and it is a constant head permeability test setup. It is one of the setup. Another is the falling head. We called all this setup as constant head permeameter. So here we have a water tank head. This tank has water in it, nothing else. Here is a graduated scale to measure the head. Now you can see here there is a water exit pipe from this tank, and this cylinder contains the sample. We can use both disturbed as well as undisturbed sample. Disturbed sample, that means we can take the sample from the side, we put in the cylinder, we compact it up to the density, and for undisturbed sample we take a large amount of sample, then we trim the sample from the outsides and we fit the sample here in the cylinder. Inside this cylinder there is a porous clean plate on both the sides, just above the soil sample and just below the soil sample. It's a porous plate, water can pass through this. So here in the setup we have a stopper to calculate the time. We have a thermometer to check the temperature, because as we know, the permeability of soil is affected by the temperature of the liquid. So here we have two jars to measure the quantity of discharge. Although the one is sufficient, but because here our setup is quite low, we can't insert the bigger one. So we will collect the water in the first jar and then we will transfer in the second to measure its volume. So we will start the flow of water in this tank, and we will start the flow from this knob. The water will start entering this sample through the porous plate. After some time it will saturate all the soil sample. We will let the water flow for some time, so that the flow should be the laminar. When we will establish a saturated soil and the laminar flow, we will now check the level of water here. That is the total head. In this case there is slight difference from what we have taken in the theory classes. Our datum is now this one. So the H2 is on 0, and for H1 we will make the total height, the water in the level, and the difference from this point up to the datum point. So from here up to the level of water here will be the total head causing the flow, and through this we can measure the discharge. And after measuring the discharge, we can use the Darcy's formula, that is V is equal to Ki. We will multiply with the area to take the discharge per unit time. So capital Q will be AKI. For a given time interval we have to multiply with the time, so that the total volume in the given time interval can be calculated. So final calculation will be AKI into the T. In this all calculation we have the discharge volume, capital Q. We know the area of this cylindrical soil sample. We know the gradient, hydraulic gradient I, to the calculation of head and the length of sample. And finally we know the time in which we have collected that sample. Now we can calculate the value of coefficient of permeability K using the equation. So in the next Hamid Bhai will conduct the lab, and he will let you know the values of these constants to you.